Okay, dear students, now comes another question. So again, here we are going to show how this limit can be proved by using epsilon delta definition or formal definition. So this basically is something different. The one we saw before was linear one, but this is a quadratic expression. So I'm going to show you how this is done. So the solution goes like this. What you need to do is you have to apply the definition first. So the definition is for every epsilon greater than 0, you need to look for delta greater than 0 such that whenever the difference between x and a comes to be less than delta, what has to follow? The difference between f of x and L must be less than epsilon, students. So we need to show this. This basically can be explained in the following sense. You are free to take any small number as epsilon. You see, whatever small number you may choose, or you may select, there needs to be a certain small number again, delta, that shows the extension of the interval, okay? Or to what extent shall we extend to the right as well as to the left? You see, from number 2, look from number 2 here, so that our x values can be taken in, and then upon substitution of this x value here in our function f of x and L5, the difference between the two can be less than the value you took. That is what is intended from this saying. So proceeding to the next one, as I said earlier, you have to replace those a and L values, f of x as well, in our expression here. So our a here is 2. As you see, a is 2, and our function f of x is x squared plus x minus 1, and your L value is 5, students. So know that a is the number where the limit is analyzed always, and f of x is a function given, and L is, you see, the number where the limit is approaching 2, okay? So once we have that, we have to substitute everything, as you see. So what comes next is, look, we need to start from the conclusion. As I tried to explain earlier, start from the conclusion and come to a situation where you can express, or you can have absolute value of x minus 2, okay? Because delta is going to be determined from that. You see, students? Unless you are not having absolute value of x minus 2, you are unable to express delta in terms of epsilon, because what we knew about delta here is delta is greater than absolute value of x minus 2. So you have to create a means of having absolute value of x minus 2 somewhere over here. You see, so start from the conclusion. So the conclusion is this, students. This is a premise, whereas this is a conclusion. So start from this one. Absolute value of x squared plus x minus 1 minus 5. This is equivalent to 2, x squared plus x minus 6, because minus 1 minus 5 makes minus 6. And factor this now. I'm now doing this because I'm on the way to get this absolute value of x minus 2. So when you think of two numbers where their sum can be positive 1 and product minus 6, you do have 3 and minus 2. So factor this, you can have absolute value of x plus 3, absolute value of x minus 2. Look, my intended expression now comes. Absolute value of x minus 2 is obtained, as you see. So you can now, you see, have absolute value property, have like this. You have to separate that. Now, students, look, absolute value of x minus 2, absolute value of x plus 3. In the previous case, you were having simple number as a multiplier. But this basically is obtained whenever you consider a linear expression. But so long as this is quadratic, expect that you should have such kind of expression as an additional factor. So we have to bound, student, we have to bound the other absolute value expression by a certain number. For that analysis, we have to come to this situation. It says absolute value of x minus 2. We are approaching to number 2. So we have to consider a certain interval containing number 2. So the question is, what kind of interval shall I take? May I use an interval containing, you see, number 2 from 0 to 3? I can. May I use an interval containing number 2 from negative 2 up to, you see, from negative 2 up to 6, I can. You are free to take any interval containing number 2 in order to find the upper bound of this one, because our limit is analyzed at 2, near 2, okay, near 2. So what we need to do is, let's consider an interval containing 2, having one extension, to, 1 unit far away to the right and 1 unit, you see, far away to the left. In doing so, we can now just take a certain delta value in order to represent, you see, that limit extension. Mind you that this delta simply shows to what extent we need to move to the right as well as to the left from the given, you see, number here, for example in our case number 2. So let's bound this absolute value of x plus 3, so that let's take delta to be 1. Guys, delta is taken to be 1 here for arbitrarily what interval. You are free to take 1 over 2, you are free to take 0.6, something like that, 0.4, 0.5, 0.1. You are allowed to take any any delta value here. Any positive delta value can be taken. But the better is when you take a small number, because the smaller, you see, the delta value, the better our limit analysis is going to be, because we are getting close to number 2. So in order to avoid decimal expression, let's consider a certain small natural number. And you know that the smallest natural number is number 1. So let's consider number 1. This is assumption, student. What am I doing? What I'm doing here is, for an interval of 1 unit length, you see, for an interval of 1 unit, for an interval of, you see, 0 to 3. How do I know 0 to 3? Because I'm going to add now 1 unit at 2 and subtract 1 unit, you see, from 2, because I'm now going to move 1 unit to the right and as well as 1 unit to the left from number 2, because I just have taken delta to be 1. But what if I take 0.5? I'm free. I am going to take, if I take, for instance, delta to be 0.5, I'm going to move 0.5 to the right, that is going to be 2.5, and 0.5 to the left, that's going to be 2 minus 0.5, 1.5. So the interval 1.5, 2.5 can contain number 2, but I just need to avoid this decimal expression. So to have a natural expression, or to have, you see, an interval with natural, with natural extension, let me just take delta to be 1. So if I take delta to be 1, look, I'm going to have the following one, students. 1 unit to the right of 2 and 1 unit to the left of 2, so you'll get an interval 1 to 3, because this interval contains number 2. You see, you are free to take other, as I told you before, but the smaller the delta value is, you see, the better the analysis is going to be what expected. So now let's find the least upper bound of this absolute value of x plus 3. The reason is because we need to take the upper bound of this x plus 3. We need to bound this inequality, okay? So for this particular absolute interval from 1 to 3, what do you think is the upper bound for absolute value of x plus 3? And in order to find that, what you need to do is you can apply directly this. Look, x is an element of 1 up to 3, implies that 1 is less than x less than 3. So everything here is positive, x is positive. But our intention is to know what x plus 3 is going to be. So let's add 3, you see, throughout, because what we are having here is x plus 3. Remember, had you were having x plus 2 or x plus 4, something like that, you could have added that number here. For instance, if this had been x plus 4, you could have added 1 plus 4, x plus 4, 3 plus 4. You can add 4 throughout. But now it is x plus 3, so I can add x plus 3 throughout. So look, this can come 1 plus 3 less than x plus 3 less than 3 plus 3. Now from this I can have 4 less than x plus 3 less than 6. So what have you obtained? Look, as you are approaching to number 2 within an interval of 1 to 3, students, you are not out of this, because your analysis is done, you see, approaching to number 2 while you go outside. So within this territory, absolute value of x plus 3 is 6. The maximum value for absolute value of x plus 3 is 6. It can't be away from that, you see. It can't be out from that. So the upper bound for this is now known, okay? So we can bound now this inequality like this. So the absolute value of x minus 2 times absolute value of x plus 3 is obviously 6 times absolute value of x minus 2. So what I did here is I took absolute value of x minus 2 as it is, but we know that absolute value of x plus 3 is less than what? 6, because this is, you see, the inequality we are having positive, so absolute value of x plus 3 is less than 6. So in place of this absolute value of x plus 3, I can use 6, but you need to have this less than sign, because x plus 3 is less than 6. So guys, now we obtained, you see, 6 into x minus 2. So if you do have this, the one you were looking for is now getting closed. You are looking for, you see, how you can express delta in terms of epsilon, but here delta was written in terms of, as you see, x minus 2 relation as absolute value of x minus 2 less than delta. Here we got absolute value of x minus 2, but in front we are having 6, you see, So I hope you have understood the mystery behind. You see why we just bound this, because we have to make, you see, the other factor of absolute value of x minus 2 to be a certain number, okay? And the one that we're looking for, absolute value of x minus 2, is remained as it is. Now if I divide the entire expression by 6 students, I can obtain, okay, this one, absolute value of x minus 2 less than epsilon over 6. So look, what I am having now is, students, what I am having now is, so we can have this, and what comes is now we have to select delta to be the minimum of 1 and epsilon over 6. We obtain here epsilon over 6, students, so we can now take the minimum of 1 and epsilon over 6. Basically, if you are taking, you see, a small difference between x and 2, obviously delta is going to be epsilon less than or equal to epsilon over 6. But if in case you are far away from, students, you are far away from one interval, you see, from number 2, or in case you are taking x value outside of this interval 1 to 3, you are free to take, you see, delta to be number 1. So what the idea behind taking minimum of 1 and epsilon over 6 is this. You see, you are free to take any x value, but make sure that the difference between, you see, x and 2, look here, the difference between x and 2 is either 1 less than 1, or it can be greater than what, it can be less than epsilon over 6, it can be less than 1, sorry, or it can be greater than 1. In case it is greater than 1, you are free to take delta to be 1, but in case you are taking the difference between x and 2 be less than, see, less than 1, you are free to take delta to be epsilon over 6. So this is the idea behind. So you do have, see, this option, so delta can be either the minimum of either 1 or epsilon over 6. So taking that delta value, one can simply obtain, or one can verify that this is proved. So for all epsilon greater than 0, you are able to take delta to be the minimum of either 1 or epsilon over 6, such that whenever the distance between x minus 2 gets less than delta, or the minimum of 1 in the epsilon over 6, this is going to happen. That is, your f of x minus L comes to be x squared plus x minus 6, and this is factored, as you see, as x plus 3x minus 2, as we did before. And this is again absolute value of x minus 2 times x plus 3, and as we studied before, look, this is the same as 6 less than 6 absolute value of x minus 2, because we said that absolute value of x plus 3 is less than 6. So 6 times absolute value of x minus 2, and this is 6 times e over c, epsilon over 6, because we have been told that, you see, delta should be the minimum of the two. But the thing here is you have to consider delta value to be what? Small number, because you are analyzing the limit of this one as you are approaching to number 2. Students, approaching to number 2 means, you see, considering the difference between x and 2 to be very, very small, okay? If that is so, the difference between x and 2 must be very, very small. If that is so, it's expected that the difference between the two is less than 1. So that's why this is taken, epsilon over 6, and this makes epsilon. So whenever, from this, whenever the distance between, look, x and 2 comes to be less than epsilon over 6, students, what happens? The difference between these two comes to be less than the value you took at the beginning, the value epsilon, okay? The value epsilon. The idea can also be verified the following way. Suppose you took a certain number epsilon, for instance, take 0.6. You are free to take 0.6. I actually took 0.6 arbitrarily. If you take 0.6 as a small epsilon value, now your delta, here it is going to be 0.6 divided by 6, okay? Because delta is epsilon over 6. So 0.6 divided by 6 is 0.1, and this is less than 1. So the minimum between 1 and 0.1 is 0.1. So as the distance between, so if you take any number between 2.1 and 1.9 as x value, the difference comes to be less than what? The difference comes to be less than epsilon, okay? Less than 0.6. This is how it is verified.